Back to part 2 of 2 on section 9.3 Bob Jones University Press Algebra 1, second edition, where we have been discussing factoring perfect square trinomials. Don't have a joke this time. Like I said in an earlier tape, I need a new collection of jokes from you guys. I want to go ahead and pick up with example number 2 on page 372 of our text. We are on example 2. Factor the following. Factor 4x squared plus 12x plus 9. Perfect square trinomials. What you're looking for here, since this perfect square trinomials, you're looking for the first term to be a perfect square and the third term to be a perfect square. This goes back to, I said, learn your perfect squares to 20. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, I wrote the answer there, 4 squared is 16, 5 squared, 25, then we have 6 squared, 36, 7 squared is 49, 8 squared is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 squared is 144, 13 squared, 169, 14 squared, 196, 15 squared. And then go ahead and you might go ahead and learn 16, 17, 18, 19, and 20, where you end up with 20 squared is 400, 25 squared is 625. These numbers here are going to show up regularly in your calculations as things to factor out, or where they are saying, okay, that's a big number, but I recognize that some of those factors in there are perfect squares. If you have not yet learned your perfect squares up to 20 squared, which is 400, do so this week. You will make your life so much more easy. In algebra, you'll tear your hair out less. Your problems will go more easily for you. So, back to our example number 2. We're going to look and see, is 4x squared a perfect square? In other words, can you take one factor, one expression that you use as a factor 2 times to come up with 4x squared? Well, to do that, you want to take the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. So the square root of 4x squared is 2 times x, which means that 4x squared can be written as a perfect square, because 2x used as a factor 2 times, or 2x, quantity squared, gives us 4x. Well, what about 9? Is 9 a perfect square? Yes, because you can take the square root of 9, and it's 3. So when you use 3 as a factor 2 times, you have 9. So, this first term, 4x squared, the square root is 2x. The last term, 9, is 3. So, following our pattern for a perfect square trinomial, in order for this expression, 4x squared plus 12x plus 9, to be a perfect square trinomial, the center term here has to be 2 times the product of these square roots. Well, what is 2x times 3? 2 times 3 is 6x. 6x times 2, or 6x doubled is 12x. So 4x squared plus 12x plus 9 is a perfect square trinomial. To factor it, you have the square root of the first term, which is 2x. You use the sign of the center term in your trinomial, plus the square root of the second term, which is 3. 2x plus 3, as I write it too. 2x plus 3, quantity squared. 2x plus 3 times 2x plus 3, let's see what we get if we actually go ahead and FOIL that out. Let me do that just to demonstrate to you. 2x plus 3 times 2x plus 3. I'm going to use FOIL, multiply the first terms together. 4x squared. The outside, 2x times 3. The inside, 3 times 2x is 6x. And the last, plus 9, sum the like terms. 4x plus 12x plus 9. 4x squared plus 12x plus 9. 4x squared plus 12x plus 9. So we have verified that the solution to our problem of factoring this perfect square trinomial is the binomial expression 2x plus 3 quantity squared. So this is our answer. Okay? Clear to everyone? If it's not, pause the video, rewind, look at it again. Okay, let me go ahead and do example number 3 from our book. Example number 3, x squared y squared. X squared y squared minus 8x y z plus 16z squared. Okay? This creature's a little bit different. Let's see what we want to do with him. Because all of a sudden, instead of just having 2 variables, we have 3. X and y and z. Numerical coefficient of a negative 8, numerical coefficient of positive 16, and of course an understood coefficient of 1 here. But there's no factor that occurs in every expression because here there's only a z squared for the variables. And there's no z squared there or here. We have a factor of 8 and 16, but only a factor of 1 here. So there's no common monomial factor that you have to take out when we do like that reverse distributive property. So the next thing that you want to do when you're trying to figure out how to factor this trinomial is say, okay, maybe it's a what? A PST. What's a PST? That's the perfect square trinomial. Perfect square trinomial, or a PST. Totally made up now because I'm getting tired of saying perfect square trinomial. It's a PST. Perfect square trinomial. That means that you have to be able to take the square root of the first term and the square root of the third term, and that this center term here has to be 2 times the product of these square roots. Well, can you write x squared y squared as a perfect square? Sure. Square root of x squared is x. Square root of y squared is y. The first term, the square root of this first term is x plus y, x times y, which means that it's a perfect square because x, y, quantity squared. This is the product rule here, so that applies to each factor inside these parentheses. So it's x, y, quantity squared. What about our third term? Square root of 16 is a 4. Square root of z squared is a z. So, if we use 4z as a factor twice, we get 16z squared. So, it's looking like this is a perfect square trinomial. The first term, x squared y squared, is a perfect square because you can say x times y, quantity, times x times y. Here we have 4z times 4z to give us 16z squared. What about this second term here? We have to be able to multiply this times 2 and end up with our second term. X times y times z times 4 is 4xyz times 2 is 8xyz. How do we deal with the fact that it's a negative sign? Our binomial here, our perfect, that is used as a factor twice, is the square root of the first term, we use this sign here, which is a negative, minus the square root of the second term, xy minus 4z quantity squared. Okay, looks a little bit different. I'm going to go ahead and verify again for you that we have exactly what we want this to be. Xy minus 4z quantity squared is the same as saying xy minus 4z, where we repeat that factor, xy minus 4z. Xy times xy, x squared, y squared. Outside term, xy times minus 4z minus 4xyz. Inside, minus 4z times xy is another minus 4xyz plus negative 4z squared plus 16z squared. Those double, x squared y squared minus 8xyz plus 16z squared. So you see that we really do have what we need. xy minus 4z used as a factor 2 times is the factorization of this trinomial here. Okay, the last example that I want to go through for section 9.3 is example 4 from our book, and they're asking us to factor x squared minus 4x plus 9. So is this a perfect square trinomial? Well, at first glance, you would think that it is, because the first term is a perfect square, and the third term is a perfect square. But in order for this to be a perfect square trinomial, the second term here has to be twice the product of these square roots here, and it's not. So this is not a perfect square trinomial, which means that you cannot factor it. Not factorable. And it's actually not factorable over the integers. You can factor this, but you don't know how to do it yet. So that's the conclusion of section 9.3, and I'll see you next week.